Hey everybody, let's go ahead and start our lesson 7 practice problems. For the first question, what it's asking us to do is kind of look over these graphs here. So it says for number 1, the axis or the x-axis of each graph has the diameter of a circle in meters. All right, so every one of these graphs, every one of them is, at least the x-axis part. All these have diameter listed, right there. So it's going to be up to us to figure out what the y-axis represents, okay? And it tells us in this problem that it's going to be one of three things. It could be the radius, it could be circumference, or it could be area, all right? So let's go ahead and get started with this. Now the ones that are proportional, let's just get that out of the way. These are proportional because they're linear and they begin at the origin. I would say that those have nothing to do with area. So the one that's area has to be the first one. All right. So I'm betting that the y-axis on this one is area. All right. Don't just take my word for it. Let's look at why that might be. Okay, so we've got on this one, I don't know if we look at diameter. So these are all diameter numbers right here. So let's say we have a diameter of 2, okay? So if we have a diameter of 2, that means the radius, keep in mind these are not radius numbers, but that means the radius is 1, okay? So we're going to do for that one, we're going to do pi times 1 squared. Which is going to be 3.14 times 1, which is 3.14. All right, which seems to kind of make sense because look right here. We kind of go up here, and that's where it kind of meets. And here's the line that represents 3, and that's just a little bit above 3. So yeah, that's got to be the area one. Let's try another one of these. And I think using 4 is a little. I don't know what you call it. Using the number 4 might be a little suspect because of the fact that the diameter or the radius of 4 is also going to be 2, and 2 squared is also 4, which means I'm just saying like the circumference is going to be the same number as the area. So it's one of those numbers. So let's do something. I don't know, let's say we do 5, Let's do 5. So so that we're going to do for that one 3.14 times 2.5 squared. 2.5 squared. All right, so we're going to do that. I'm going to use my calculator here. I got 19.625. Let me just make sure this is clear. So when R equals, I should do it like this actually, when D equals 5, right? R equals 2.5. And when I do that, I got 19.625. Practically 20, right? Well, not too that far from 20 at least. And so if I check out that number there, here's 5, and I kind of track my way up there until I meet the line, and there it is, right there. So yeah, that looks about like in the 19 vicinity. So that's got to be it. Okay, so this one is no doubt about it. That is area. That axis, the vertical axis, the y-axis, is area. All right, on the second one there, we've got a very proportional. Well, the second and third one are very proportional because they begin at the origin and they are linear. All right. Now the thing that kind of sticks out for me on this one is I notice like every time we look at a diameter number, like the diameter is 2. This number is 1. That's kind of weird. It's half, all right? So if I try, let's say the diameter is 4, I get 2. Well, 2 is half of 4. All right, let's try 6. So if we do 6, we get 3 on the y. That certainly looks like the relationship between the diameter and the radius, okay? So that is got to be radius, okay? And then so that means, just through basic deductive reasoning here, guys, basic deductive, that this one must be circumference. And circumference is a proportional relationship. That is going to be perimeters are proportional relationship. Area, anything area is not going to be proportional. Okay, number 2. All right, circle A has an area of 500 square inches. The diameter of circle B is 3 times the diameter of circle A. All right, now when I was helping somebody out in class on this one, I mean, there's another way to do this, but when I was helping somebody out in class, I just kind of said, let's make a simpler example of this. What I did was we kind of just, let me just adjust my markers here. What we did was I just drew a small circle, and then gave that a diameter of something really simple like 2. You know what I mean? So a simple diameter like 2. Looks like 1, doesn't it? Let me draw that better. All right, there's 2. So you got a diameter of 2. And then it says in this problem, it says that certain, and this is circle A, by the way. It says in this problem that circle B has a diameter that's 3 times that. 3 times that. So that means the diameter for circle B is going to be 2 times 3, which is 6. Now this is probably not to scale. Definitely not. So that means that has a diameter of 6 right there. And what I just wanted to do there is just kind of compare the areas. Let's kind of compare the areas that we get, because that's what it wants to, because it's saying that the area, of circle A has an area of 500 square inches. Now, this one certainly is not 500, okay? Don't get me wrong. That is not 500. That's going to be way less. But I'm doing this just to see what's the relationship between the area of A and the area of B when I multiply it by a factor of 3, make it 3 times bigger. So that's what I'm going to do. So I'm going to do for A, we're going to do pi times radius squared. Now the radius, keep in mind, radius is half the diameter, so it's going to be 1 squared. So 3.14 times 1 squared is going to be 3.14. Okay, so I'll put 3.14 square inches, okay, on that one. And that's for A. Okay, that's for circle A. And then for circle B, we're going to do the same thing. We're going to do pi times, and the radius on this one is 3, because the diameter is 6. So we're going to do pi times 3 squared, which is going to be 3.14 times 9. All right, so 3.14 times 9 is going to be like 28 something. So it's 3.14 times 9, that's 28.26. I don't know why I don't have those memorized, because I do this so often. But yeah, that's going to be 28.26. Square inches. Okay. Then the second thing we did when we looked at these values here, second thing I did was, okay, now let's look. How much larger, because obviously one of them's larger. How much larger is this one? And I know I put A in there, that's B. Sorry about that. I put A for area, but I don't want to confuse you. That's area of A, or B, and this is the area of A. Okay, but how much larger is B than A? All right, so if you want to figure that out, just divide. Let's just do 28.26 and divide that by pi, basically 3.14, and see what you get. All right, so when you do that, 28.26 divided by 3.14, you get 9. You get 9. So that equals 9. So what I kind of notice here is that this grew by a factor of 3. You know, the area grew not by 3. It grew by a factor of 9. I meant to say like 3 squared. It grew by a factor of 3 squared. And so that's going to happen with the same thing. So that basically just means you're going to take 500 square inches and you're going to multiply that by 9. You're going to multiply that by 9, and that will, that will be a circle that has a diameter that's 3 times the diameter of the original one. So when you do that, you get 4,500 square inches. Okay, number 3. Lynn's bike travels 100 meters when her wheels rotate 55 times. What is the circumference of her wheels? Okay, so going 100 meters 55 times, well, I mean, and we just want to find circumference, like what's 1? So this is just division. This is just division. So I would, for this one, if we just do 100 meters divided by 55 rotations, right? If we do that, I'm going to put R for rotations, we're going to get how many meters it is. We're going to get the unit rate. We're going to get how many meters it is for 1 rotation, So we're going to do 100 divided by 55, and I get 1.8181. No, it's repeating. So I get 1.81 repeating. All right, and so if I just round that, I guess, to 1 decimal place, I'm going to get like 1.8 meters. That's the circumference of 1 wheel. 1 8/10. All right, number 4. Priya drew a circle whose circumference is 25 centimeters. Claire drew a circle whose diameter is 3 times the diameter of Priya's circle. What is the circumference of Claire's circle? That's a sneaky problem to put in there, because we just did, if we look at the second problem right there, that was not a proportional relationship, right? That was, just because the diameter was 3 times bigger did not make the area 3 times bigger. But if you remember, area is not a proportional. Like when we look at area and how it relates to diameter or radius, it's never proportional. Okay, it's exponential, really. But it's but circumference, however, circumference is proportional. So multiplying by 3, her multiplying the diameter by 3 will do the same thing to the circumference. So all you have to do is just take Priya's circumference and multiply that by 3, and that will equal Claire's circumference, which will be 75 centimeters. See, it's as easy as that. All right, next page here. All right, number 5. Here's a picture of 2 squares and a circle. Use the picture to explain why the area of the circle is more than 2 square units, but less than 4 square units. So the area of the circle is more than 2 square units, but less than 4. Okay, so, well, I mean, it's kind of obvious. I mean, the square, if we look at, it's not totally obvious. Well, maybe on my copy it's not so obvious. But the square right here, the square is 2 by 2, right? So that's 2 units by 2 units. So that's, so the square has an area of 4 square units. And then you can see, just by looking at it, just by looking at the picture, right, you can see the circle does not fill in that entire area, right? There's a bunch of empty space here, and here, and here, and here, which tells us that it's less than 4. Okay, so that kind of confirms the first part of it. All right, so, well, that's the second part. It's less than 4 square units, that's for real. All right, and then I'm going to erase this. But we want to see why it's greater than 2. It's greater than 2. And now there's a square in there that's kind of drawn in a tricky way right here. It's drawn like this with diagonals, if you look at the you're looking at the diagonals there. All right, now to find the area of that square, what I'm going to do is I'm going to decompose that shape. I'm going to break it up into, I don't know if you guys see this, two triangles basically, two triangles. And so this is, that triangle right there has a height of 1 unit. That has a height of 1 unit and a base of 2. That has a height of 1 unit and a base of 2. And so now we can just do area of a triangle. Area of a triangle is 1/2 times base times height. All right, so 1/2 times 2 is, that's 1, right? That's 1, and 1 times 1 is going to still be 1. Okay, so right there, let me just make sure this is clear. Just that triangle alone, just that one, that has an area of 1 square unit. And the other half is exactly the same area, right? So this one will also have an area of 1 square unit, which makes that 2. Okay, so that whole thing is 2 square units. And right there you can see that the circle is bigger than that shape, right? That entire square shape right there fits inside that circle with some space left over, just right here and right there. These little arcs right there. For B, here's another picture of 2 squares and a circle. Use the picture to explain why the area of the circle is more than 18 square units. All right, let me just stop there. More than 18 square units. The area of the circle is more than 18. Well, we could just use what we know about circumference. Like I did on the last one, I didn't really do that, but I should say what we know about area. We know about area. This is area, right? Area equals pi times radius squared. Pi times radius squared. And so on this, for the circle at least, the radius is 3. All right, so you're going to do, I'm just going to do 3.14 times 3 squared. All right, so that's going to be 3.14 times 9. All right, and the area is now 28.26 square units. Okay, so that's more than, all right, so why the area is more than 18 square units? Well, that's right there. I'm showing you that right there is definitely greater than 18. That's 10 greater, right? A little bit more than 10 greater, but it's over 10 greater than 18 right there. And then it says, and tell us why the area of the circle is less than 36 square units. Less than 36 square units. So, well, that right there is going to depend on this square. And this square right here, the square that is surrounding that shape is 6 by 6, which is 6 by 6. And 6 times 6 is 36. So the square has an area of 36 square units. So that's got to be, right? That's got to be smaller because look, there's that circle fits in there, and we got this empty space left over here, which is not part of the circle. So it's got to be less. It's got to be less than 36. Not like a ton less, but less nonetheless, I guess. That's a weird thing to say. All right, last question here for number 6. Point A is the center of the circle, and the length of CD is 15, which is already drawn in there. So find the circumference of this circle. All right, so point A is the center. This is easy. So circumference equals pi times diameter. Pi times diameter. We didn't even really need a picture here, but we can just do 3.14 times 15. All right, 3.14 times 15. That's 47.1. centimeters. Now remember, circumference is not squared. It's just a distance. It's just a length of something, but it's not squared. Area, we reserve that for square units. That does it. All right, I'm finished.